we will see that what is the SPDF block elements mentioned in the periodic table. So if you see extreme left side, this is the S block element. That means lithium, sodium, potassium, etc. And it has the group 2 also. That is group 1 and group 2 consist of the S block element. Group 13, 14, 15, 16, 17, 18. These all belongs to the P block elements. And D block elements consist of the groups 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in separate table, F block elements is there. We know from our previous class discussion that those are the lanthanoids and actinoids. There is some two exception is there. One is the position of the helium and another is the position of the hydrogen. So helium, if you see that its character is noble gas, that means it is inert gas, and that's why it is placed in the top of the group 18 along with the other noble gas. And another was the position of the hydrogen. For the hydrogen, if you check, it has only one electron, one S1. So it will be like that S block element, especially for the group 1 elements. And also with one S1, if you add one electron, then immediately it will get the electron configuration like helium. That means this hydrogen position may be in the top position of the group number 17. That means above F. So from group 1 to group 17, this hydrogen element can stay in the periodic table. So that is the reason it is a special case for the hydrogen. So the hydrogen is placed separately at the top of the periodic table in this position. So now we understood the SPDF block elements and where is their position in the periodic table. For the SPDF block elements, the above principle I already discussed in the previous class in the unit number 2. This above principle and the electron configuration of atoms provide a theoretical foundation for the periodic classification. The elements in the vertical column of the periodic table constitute a group or family that exhibits the similar chemical behavior. And this similarity in the chemical behavior arises because these elements have the same number and same distribution of electrons in their outermost orbital. We'll check it now with the S block elements. So the group number 1, that you see the alkali metals is there, lithium, sodium, potassium, etc. Every element of this group number 1 outer shell configuration is NS1. That means for the lithium it is the principal quantum N is a 2, that's why it is 2S1. Then for sodium 3S1, potassium it is 4S1, outermost electron shell configuration, and so on. So from the previous discussion, that outer shell configuration, number of electrons, if it is the same, then is group wise these elements behavior chemical behavior and other behaviors have the similar properties. And for beryllium also, if you check the electron configuration, then outer shell electron configuration is NS2. That means for beryllium, it is the 2s2 outer shell electron configuration. For magnesium, it is the 3s2 outer shell configuration. For calcium, 3s2 outer shell configuration, and so on. If you go for strontium, barium, etc. So the NS1 and this NS2 outermost electronic configuration belongs to the S block elements. These are all the S block elements. They are all reactive metals with low ionization enthalpies, because it is ready to donate the electron, which we'll know in details during the class for the chemical bondings. And that is the next unit. That means these elements ready to lose the outermost electrons to form the, for the group 1, the +1 charged ions, that means singly charged ions. For alkali metals means group 1 elements, or the doubly positive charged ion to form for the group 2 elements. And group 2 elements, it is generally called the alkaline earth metals. And their metallic character. Their metallic character and reactivity increase as you go down the group. Second point, because of high reactivity, they are never found pure in nature. So this is very highly reactive. So these elements always will be in nature as compound. In pure form, it is very rare because of its high reactivity nature of these elements. The compounds of S block elements, with the exception of those of lithium and beryllium, are predominantly ionic, except the first element in group number 1 for lithium and first element of the group number 2, that is beryllium. Except these lithium and beryllium, other compounds of these elements are predominantly ionic.